Hello and welcome back really quickly. In my last video, I set this as to get URL because normally I have this set to URL just because that is the website, or I just use it because that's the URL that we get it from. But I chose DDB and I made a mistake, and so I fixed it. So now this cell is more complete. So what we're going to do now is take our data from, the DDB and apply it to the Antoine equation, where P is pressure, C is temperature, and A, B, and C are all constants. So what we're going to do is take this. So we have our data set as an array. So what we're going to do, we're going to say, let's do E for equation. How about that? Data from 0 to wherever it ends. We'll do that. And we'll do log of pressure of vapor, because that is what the Antoine equation is. NumPy log base 10, because you have to do that, is 1000 times our data. And we're going to set that. Oh, nope, that's not a bracket. There we go. 1 to where? Oh, nope. To wherever it goes. So that should be that. So now let's do a base plot real quick. So fig is equal to make subplots. Oh heavens! Oh goodness! There we go. And we need to do fig add scatter, so that way we actually have a plot to use, and we'll say the x-axis is equal to, what do we call it, E, and the y-axis is equal to log PV. And let's use markers because it's impossible to see anything on a graph without anything to mark it. Oh. I'm not sure why that did that, but we can keep going and we'll see if we get something in the future. So we're defining our model A, B, C, and E. Nope, that's a T. E. Okay, so let's do that, and we want to have Python return, or give us back, A minus B, what is it? A minus B over C plus T. Perfect. So let's come back here, over C plus E, because that's what we used it as. You know, let's go back to T, it's a little bit easier. Makes everybody a little happier. Oh, goodness. Oh, gosh. Sorry about that. Let's shift enter here. We'll shift enter there. I don't know why that's actually not giving me a plot, but it isn't. Okay. So now what we are going to do, oh, you know what? We need to add the minimize function. So we can minimize error later in the code, but that is coming right now. So we're going to do the sum of our squared error. Oh boy. VT log P, oops, PV. We need to do our first value, our second value, Our third value, that's a 2, or that's a 3, not a 2. Our third value, and we need T for temperature. Oh gosh. Careless, careless, careless mistakes. Our sum squared error is equal to, oh goodness, see, something else we need to add in here. We need to import, actually no, I don't think we do. I take that back. Actually, yes, let's. I'm sorry about this. Import, we need jacks. We need to import, oh goodness. Import jacks numpy as jnumpy, or np. And that should be that. Now, we come back down here and we say that jacks numpy is the sum of our squared error, which would be log PV minus model of log PV squared. And in Python, you have to do 2 asterisks, and then we want, oops, Python to give us that back. Oh, you see? Careless mistakes. I did it again. How about that one? Invalid syntax. Oh, I see. I took a bracket from my 2 and put it behind the T. That would be why. Alright. So, we should... Let's do guesses for our values. Oh goodness. You see, I did it again. And these are all equal to... Oh boy, this could be fun. You want to pick values? Let's do... How about... We'll do... Oh, let's do 10. And we'll do 1,000. Nope. 1,000, and then, oh, no, I don't know what that is. It wanted me to put something in there because I put a period, and let's do 0. Okay, so our error is this, then our, sorry, I'm not doing a great job of explaining right now, but we need to take our guesses and import all of them, and we need our temperature and our X and our Y, I guess you could really call it that. So bad spelling. Things are looking good so far. So now we need our result. This is when we bring in minimize. We want to minimize our squared error. A guess, B guess, C guess. These are our arguments here. Psych, no they're not. These are our args. We need temperature and our log PV. And then we need to do... My parentheses lined up correctly? No. There we go. We need this. And that is equal to our gradual square error. Nice job. Good job. So now, here comes the application of the Antoine equation. Please work for me. It would be a sad venture if it did not, but we make sacrifices and we overcome. Y is equal to model. We need the result of x 0, which is our initial guess. The result of x 1, which, nope, that's a 2, and I messed it up again. See? These fat fingers, I tell you what. Of our second, see, I did it again. And we need t. And then we put that, and we say we need mode is equal to, and this should give us a plot of, oh heavens, well, what should happen is right here, the plot should look like this, because this is the data that we took from DDB of just the original raw data, and then this is the Antoine equation applied. So I'm not really sure why our plots didn't work, but that should be the application of the Antoine equation and the data collected from the Dorman Data Bank. Thank you.